Hello, this is Tariq L1. I'm here today to present you the SBM4104, the IT infrastructure unit. Today I'm gonna present the lecture number 2. What we will cover today, the first piece of the first half of this lecture, I'm gonna go over some kind of basic concept about the IT infrastructure. And the second piece of that lecture, we will cover the OSA model as introduction only. We will cover that on the next slides or the next lecture. So what we will have today, we cover last session what's the infrastructure, even we define that the infrastructure. Today we will go over just an example, a model of that infrastructure. Then we will move over the non-functional attributes and functional attribute as well, building blocks, and we will move to the read area of networking, which is the computer networks. So last session we went over the word infrastructure, and I mentioned to you that the word infrastructure, it's actually Latinos, which is infra, beneath or under, and structure. And we usually, when we talk about the infrastructure, we mean that the city, water pipe, electricity, gas, sewage system, and telephone line, gas pipes, anything underground. In IT, we talking about the infrastructure, which means that the hardware in reality. However, we include as well the software, because without software, the hardware will not be able to work by itself. This is one of the basic building block model in IT. Just only to understand that very basic concept about that. Let's define first. As you can see at the top, we have process or information. The process is a piece of information. It needs to be executed either by application or either by processor or whatever. But at the end of the day, a process is a piece of information need to run. Run by what? By application, which is the second layer. The application, usually different type of applications, which are used usually as well different type of protocols, and the applications need to run some specific services, and these services we call it platform. So if you type, for example, in the CMD, if you type services that just only MSC, you will find plenty of services is actually running on your computer to make it work. As you see right now, we have to run some services, we call it application platforms. So to go backward again, let's go. The piece of information at the top need to be run by application. That application need a services, which is what we call it platform, from top to bottom. These ones, the process which run on the application, which need services, the application platform has to come on the top of an infrastructure, which is the devices. As you can see in the user devices, we will cover that, the operating system, the compute, the storage, the network, and the data center. We will cover one piece by piece. All that platform has to be available. We evaluate that system in terms of availability, the performance, and security as well. So these three let's say, titles has to be implemented correctly and directly within the building block models, the availability, performance, and security. We have what we call it functional attributes and non-functional attributes, and we will go over that as well. So what is the process exactly? Piece of information need to be executed or process, but I don't want to use the process to define process. To be executed or managed. To manage by what? By application. That application need to be managed by application management system. However, that application need what we call it services. Those services run as a platform. What kind of services we have? We have plenty of services. As I told you, if you run just the command services MSC, you will find that plenty of your services in your computer, which I'm gonna show you that during the lab time. We have services which run for front-end server, like web-based servers, any server which you can host as a host, website for example, or application services, like servers, which can be Java, .NET, but in short, that's usually, when we mention that application servers, we mean that the desktop computer or desktop services. We have connectivity and we have database. And database, we have the one you may be familiar with, the Access, Microsoft Access, but this is like very basic. We have SQL, very popular, and we have Oracle, which is top professional one. The infrastructure building blocks, when you go under the infrastructure over here, under the infrastructure, you will find few infrastructure management under tools need to be implemented. What is that exactly? We start with the end user devices. What is the end user device? The devices you use it in hand. For example, desktop, yes. Laptop, yes. Mobile devices, yes. Printer, yes. Whatever at the end which is facing the user. In short, any device which is, or mostly devices which face the user, the end user, which is us, or in your term, students, that's we call that end user devices. Operating system, to understand what is operating system exactly, it's a program, a software program, usually took over or use in the top of the hardware. We install it in the top of the hardware so I can manage the devices, or let's say the tools, the hardware. If I have a server, but I haven't installed anything on it as a hardware, but I haven't installed anything as an operating system on it, there is no meaning. There is no meaning to do that. So we need a program which I can install it in the top of the hardware so I can manage this hardware. I can do management. Not just the hardware in terms of storage, but I can start to use that to communicate outside, to communicate internally and externally, and I'll save data, upload data, and so on. Virtualization, sorry. Virtualization, it's involve a layer between hardware and the operating system. A management layer, small layer, usually located between the hardware and the operating system. To do what? To break down the hardware to look like actually multi-hardwares. So I can break down the static hardware to make it dynamically breaking down into multi-machines. We will cover that, by the way, and we have a chapter fully on cloud computing and virtualization. However, just remember this concept for now. And by the way, that layer which is located between the hardware and the operating system, we call it hypervisor. The storage, we have different type of storage. We have what we call it the NAS, and you can see it, they're just like image for that next to that. That's one of the image. I just put it for you over here. You can, as you can see over in that image, you can see there is like 4 hard disks inside that storage, network attached storage. We have storage area network, which is actually network built for storage. So a complete network which is involved with high speed storage area and high speed switches, very advanced like fiber optic cables between both of them. However, the whole network designed to become a storage. And this one usually we use it in cloud computing and to store data. Most of the data center, they use that to store data. A huge, massive network designed only to work as storage. The DAS, which is direct attached storage, any external storage, start from the USB to a small portable hard disk, whatever it is, we actually consider that one as direct attached storage. The networking, you may be familiar with the concept LAN, MAN, WAN. You can add to that as well PAN, which is personal area network. However, for the LAN, the local area network, which is a network cover a small area, limited area, something around like a 1K or almost less than 1K, 800 meter, 900 meter, something like that. In some references, they say that it's up to 1.2 kilometer. However, in short, to understand that, something to cover a network which is a smaller area. If you go for MAN, MAN, metropolitan network, that's usually cover something within a city, a network within a city. For example, we are here in Sydney, the network we have in CBD, we have another branch, for example, in Redfern, still that we consider that as MAN. It's within the same city. The WAN, which is city to city, or sometimes country to country, or continent to continent. Anything beyond city to continent, that's become a WAN, wide area network, which is another story we may cover that during the lab as well. Servers, what servers exactly? Supercomputer. Supercomputer. What you mean by supercomputer? A computer but has high level of processor, high level of RAM, high level of motherboard functions, high level of graphics, high level of network card, everything. And usually we consider that, and those servers usually has an operating system, a server operating system, not normal as Windows 8 or Windows 10 or user one. We have server, the famous ones, which is the Windows 2012, 16, 19 currently in the market. However, we have multi-type of servers if you want to run on it from different use. We have plenty of servers. So can be an FTP server, can be web server, we can be email server, can be many things. DHCP server, which you will see later on. However, it has a operating system different from the single user as Windows 7 or 8 or Mac or something like that. The data center, you maybe you came close to the Google data center, for example. If my memory still works, Google has almost 60 data center until 2019 statistics or 2018 statistics. I'm not sure exactly if they went over that or not. They have around 60 data centers around the world. During the lab, I'm going to show you just a quick video about how to look data center. Something a massive, sometimes like on the size of a football area, playground, which you put a lot of servers, racks, cooling system, a very powerful system. We use this one to keep data, process data, and provide services as well, which you will see on the AWS later on week 8. The infrastructure management system, any network, if you have a real network, not home network or something or small one, if you have a university network, for example, or a big company network or banks, whatever, you need to have a central management system or distributed management system. So you need someone to look after your network in terms of hardware, software, connections, communications, bandwidth, problems, logging in, backup, many things. If we try to talk about the non-functional and functional models, for example, what is that non-functional and functional? Very basic. The function, if you provide services and you can actually decide what services exactly in steps, that means that's functions. If you try to provide services which is non-functional and that's related to the quality or the performance, so which means that there is no static actual real number for it, that become non-functional. For example, let's go for very basic example. If you try to increase or add a storage area to one of your clients, yes, that's very basic. You call me, I want extra storage. Yes, I'll go to the server, give him another 20 gig, no problem, done. That's functional. That's functional. That's really functional. Will define function. If you want to install a software, for example, yes, you ask me for software. Yes, I'm gonna go install your software. That's function. Will define function. Something I want to route data. Yes. Can you provide me with virtualization? Yes. Can you install for me at HCP? Yes. Everything is will define. But when you ask me or you try to describe something, what we call it quality or qualitative behavior, what is that exactly? Something you tell me how the bandwidth in your system. I can give you estimate of that, but I cannot give you exactly what is that. How the security in your system. What do you want to? Can I describe that? Very well. Excellent. But that what you mean by excellent? Is that 100%, 98%, 99%? You can't. But it's good. Something like when you try to describe HD, D, C, P, whatever, it has a level of between. So you can say, I have a good security. I have better performance, less performance. The availability, yes, it's almost 24/7. Yeah, it can be available anywhere, anytime, any device. So when you try to describe something based on quality, which means that you cannot put exact function for it, which means that this is a qualitative behavior. For here, I add you another option in the tab of security, performance, and availability. I add you something called reliability in networking. Reliability, reliable system. How that system is reliable. Example of non-function and example of functions. What is the component of a network? If we as we talked last lecture about the client server architect, peer-to-peer architecture. What is that exactly in terms of, since we mentioned that more than 95% of the network around the world based on client server, the actual network component currently you need a server or servers, sure, with S as well. That server can be different type of servers. Can be mainframe, which is the old technology, can be a normal server, which is what we have currently. Can be web server, DNS server, DHCP server, FTP server, whatever it is. Email server, sure. In short, you have a server which provides service, and you have a client which requests the service. And between the client and the server, you need some connection. How you connect? For example, do you connect through what? Fiber optic? Do you connect through the normal cable RJ45 connection, which is the Ethernet cable? Do you use wireless or Bluetooth or using infrared or satellite? That's what we call connection or circuits. Connection or circuit. What is that exactly? Do you use cable or you don't? What kind of connection between the server and the client? What's in the server? Usually has a software, either operating system, or you can install something like DNS, DHCP, FTP, email server, whatever you like. But in short, the server have a software, some type of software. The client, you can access that server through different type of input or output, such as you can access that through a desktop, laptop, mobile devices, whatever it is. The circuits, as I mentioned to you, that there are type of circuits currently, either wired or wireless. Wired, we have many options. Wireless, we have different options as well. This is the comparison between LAN, MAN, WAN. The LAN, small geographical area. MAN, within a city. WAN, more than a city. So if you have, for example, a company has two branch from here to Melbourne, one here, branch here, another branch in Melbourne, that's become a WAN. If you have two branches in the same city, MAN. If you have one branch only in a small area, that's LAN. The network devices, we can break these devices into interfacing devices. And remember the word interface because you will use that to configure the Cisco routers and switches in using packet tracer. During the lab, you will use the command interface, and you will understand the word interface when you say that interface Giga Ethernet 00, interface Fast Ethernet 00, like that, which is the end connection of the link, whatever that link into connection. if you actually using a laptop, you have many input ports in your laptop. For example, you have an input port for the LAN cable. You have another one for the US, or two for the USB. You have a third one for maybe the audio connection. You have another one for CD or whatever. What we call those ones interfaces, which is the end of terminated connection. Transporting devices, connecting devices, and routing devices. Let's go with the routing devices because the routing device is the easiest part. Routing devices involve routers and layer 3 switches. Routers and layer 3 switches. Do we have another switches? We have what we call it layer 2 switches. And layer 2 are not routable, not. Layer 3 only work as a router and switch. So what is the interfaces exactly? Any interface which can send and receive data over the link or the medium, we call that interface devices. And you will, by the way, you will practice that during the lab today, or read that in week 2. The transporting devices, we have example of taking the data from one location to another location, from one device to another devices. And this one involve with the media converter, transmitting or receiving, repeating, line encoding or decoding, and chain multiplexing and multiplexer. What's that exactly? Media converter, for example, you sending the data from your laptop through the gig Ethernet cable. Then that one will jump into the ISP, the internet service provider, like Telstra. Telstra using fiber optic. Here it is. We need to convert that medium or that data from gig Ethernet, the data on it, to the fiber optic. We need something to convert that type between those two medium, a cable type to another cable type, medium type to another medium type. Transmitting the signal, you may understand that much more in terms of wireless. When you transmit or receive signal or repeat signal, usually transmitting and receiving, maybe you may familiar with that in terms of wireless. Repeating signal, when you, for example, when you are home and you take your phone outside in the backyard and you try to connect to the Wi-Fi, that's really low signal. What we do exactly, you can buy something called repeater. What is a repeater? Exactly something which you can take the signal, the weak signal, strengthen it, and send it again. The same signal, just to only make it much more powerful so you can reach it. The line encoding and decoding, that's involve converting between binary to hex to binary from one medium type. For example, if you want to encode one type of video type to another video type. For example, you have something MP4, you want to make it VLC, like this. You need some kind of encoding and decoding. And if you're familiar with some kind of music equalizers, you may understand that as much. The concept which is you may need to understand the multiplexer or the multiplexing. What is that channel multiplexing? In short, the coaxial cable or the fiber optic cable or the TV cable, you actually have it at home. It's one cable, but in that cable I can watch TV, like Fox, for example, or whatever it is the company provider, and I can get as well phone in the same cable. Yes, in the same cable. And I can get actually internet in the same cable. Yes. Can I get fax services in the same cable? Yes, it is. So I can get a TV service, phone service, internet service, fax or services on it. Yes. How is that? That's what we call channel multiplexing. You break down one physical cable to multi virtual channels. That's how it is. Yes. For example, a very easy example, if you want to see something like that, if I have a cable like that cable, for example, whatever that cable type is, this one, for example, has 5 megahertz. So what to do exactly? I can break down that into different channel, kilobits, kilohertz, kilohertz, like that. So what to do exactly? I can put here 2, I can put here 1, 1, 1, like that, and assign that channel into, for example, the TV, that channel into the phone, that channel into the internet, and that channel to the fax, and so on and so on. By the way, if you have more services, feel free. If you have more, feel free. What is that exactly? One physical cable, whatever the cable is, and I break it down to carry multi different services in the same cable. What we call that? Multiplexing. Interface devices are connecting devices. The connecting devices, we usually, if you're familiar with the switch usually have something like that. You will see that, and that switch has ports, and you link your cable here, and someone else link it here, and someone else link it here, and so on. It's multiply of 24 ports, multiply of 24 usually, especially in Cisco one, multiply and 24 and 48, whatever, like that. And that's the switch. Hub, it's a dumb device of the switch, which means that it's not a switch, but you can say that central connection or communication area, like patch panel, for example, but little bit smarter patch panel, but it's not smart as the switch. The switch is much more smarter and has a lot of function beyond the hubs, a lot. The hubs is what we call a dumb device. Routing, you need a router or layer 3 switch, which is much better than the router, the actual router, and much more expensive. The difference between router and switch, the layer 3 switch, the layer 3 switch is much advanced and much faster in terms of converge, and it can work as a router and switch, but the router is router only. What's the job for the router? Routing. Take your data and you have a router here. This is my router, and this is my connection. For example, this is my network. Here I want to send the data to Google. For example, I want to get data from Google. I try to type in my browser here. I want to go to google.com. What is that router will do? Will try to search for, let's say, the best path and the shortest path to reach Google, or send your data and bring your data back as well, the other side. That's the job for the router, the main job for routing. However, the router has a lot of function more than that. The network model, and this is the one we will cover today and the next 4 weeks. What's that exactly, the models? Because that's really important concept. Last lecture I went over something called consistency. We want to have consistency in industry as an IT. How we create consistency? We need to create some kind of networking models. Everybody has to follow that model, and what we call that standardization. A lot of organization like IEEE, ISO, ITU, ITMU, many, what they do exactly, they come to publish. Sure, study first, then decide it, then publish. What they publish, their recommendation or their, let's say, rules. Everybody or all the company around the world has to follow that to manufacture and their product according to that. That's why you see that every cables related to the network in the world has the same size, the same connector, the same thing. If you have the USB, it can fit in anywhere, everywhere in the world, at any device, and so on and so on. Like, put that under standardization. How we came to standardization? We have what we call it model, network model. What is that network model? I want to send a data. So I want to understand the concept, how to send data. What happened exactly from sending data to until the data received by the receiver. What happened between here and over there. So we need to break down these steps into what we call it layers. And each layer usually has two things, services and functions. What that layer has, services and functions. For example, instead of putting everything under one layer, whatever in the network under one layer, when you try to troubleshoot for something, it's going to be really hard to figure it out where it is. But if I break that into multi-layers and I put specific things inside these layers, so it's gonna be easier for me to troubleshoot, and also it's gonna be easier for me to understand what's going in each layer, and I can at that time try to develop product to match that area. Two main models. The old model, which is the what we call TCP/IP, the one in the right. As you can see here, it used to be application layer, transport layer, internet layer, and network access layer. And each one has function and services. And that developed by the DARPA, which is the defense. However, after 10 years, 15 years, 20 years, they realize, oh, that's a lot. For example, in the application layer in the TCP model in the right, we have plenty of different function and services inside that layer. And what they come up with, okay, let's break this layer into 3 different layers. As you can see over here, we break this one into this and this. So those ones, these 3 layers, actually in the OSI model, what they call it OSI model, the new one, it used to be 1 layer in the TCP model. It used to be here. Okay, the transport layer still the same. The network layer, over here they call it internet, over here they call it network. When it comes to the network access layer, we break this one into 2 different layers, and we call that data link layer, and that's physical layer. By the way, that one actually been break down as well in another story. If I get chance, I will explain that to you as well. That's extra. But as we actually moved to the OSI model, we break that down into 7 layers. It becomes 7 layers, and that's what we will study from today until another maybe 4 weeks. We will go over those layers one by one, the 7 layers, the application, the presentation, session, transport, network, data link, and physical. I want you to remember that this is this is layer 1, and this is layer number 7. So when we say that layer 2, that means the data link. Layer 3, that's the network. Layer 4, transport. Layer 5, session. Layer 7, the application. From bottom to up. What's exactly in that layer? Each layer has functions, and that's the one which I reckon you to focus on. What's in the application layer? I'm gonna try to maybe email you a piece of page which has a Word document which has summarization for the function and the service and protocol for each layer. In short, if you want to summarize the application layer, something related, it deal with any application running programs on your computer. That's very basic fundamental things, and we will cover deeper as of next session. The presentation, as it said, presentation, it involves with the formats. Format of your document or your data. Do we have different format? Yes, we have the binary format, you have the text format, you have the ASCII format, which is different story, and we have many. That layer, the presentation, does as well what you call it compression and decompression as well. The layer number 5, which is the session layer, as the name mentioned, it involves with establish, maintain, terminate sessions between similar devices, sender and receiver. The transport layer, as I put you over here, you can see that what's the transport layer? We focus on the end-to-end connection. What's happening between the sender and receiver? The network layer, and that has 2 major functions. Let's say, what is that exactly? Or services. Routing, that's the main function, and logical addressing, which is the IP address. Again, the network layer, routing, and logical addressing. And we will cover that in details, but that's right, just very basic for now. The data link layer, it deals with error control and this is one of the most important function, the error control. Yes, it has to terminating the message, something like that, it's okay. But the main concept of the data link layer, one of the main functions, the error control or error correction, if you want to correct the errors. The physical layer, that's the one responsible for converting the binary, because you actually say your data in terms of 010101. Good. Now I'm gonna send that using wireless. How to convert that my data into wireless? That's the whole idea. So how to convert the data 0101 into a signal or transmitted signal. It depends on, by the way, if I'm using Ethernet, how to convert it into the Ethernet. If I'm using a satellite, how to convert it into a satellite signal. Using Bluetooth, how to convert this data into Bluetooth data, and so on and so on and so on. And that's sure usually the area which is you connect the physical layer. This is the area which you connect, as you can see over here, the end of the cable. That's the RJ45, and this one is the fiber optic connection. Over here, which we will cover later on, what is MAC as well, the routing addresses. The layer 3, as you can see here, routers. Routing. Determine the path and logical addressing. The transport layer over here, end-to-end connection and reliability. The session, as you can see here, connecting session. And by the way, that's that session when you connect to your bank, for example, or even you connect to the Epic RTO, or you connect to the Canvas. If you don't use the Canvas, for example, you log in and you didn't use it for 20 minutes, for example, what's happening usually? Terminate. What's that terminating? The session. You have a session with the server and you haven't used it for a while. This is the session layer responsible for establishing, maintain, and terminate the logical connection, the session between both devices. One of the things which is I want to show you here, each one has something like this. What is that? FTP, SMTP, whatever. What is over here? For example, MP3. What is SIP, TCP? What is RTP? What is TCP, UDP? What is these things? Mostly protocols, what we call it protocols. What is that protocols are? Protocols is like sets of rules. To understand that, you need to, let's say the HTTP as a protocol, which is the one you use every day on your device. When you type anything on URL, that's HTTP or HTTPS. However, what is that HTTP or HTTPS? A protocol. And that protocol is what? Sets of rules. What rules? How to connect, what to connect, when to connect, how to terminate, when to terminate, what like that. How to maintain the connection, how to terminate the connection, how. That's how it is. It's all about rules in programming language. It's all about sets of rules. Any protocol, sets of rules, different rules for sure. That's why we have different type of protocol, as you will see. As you can see over here, for example, routing protocol, we will have OSPF, and you will have IP, for example. You have troubleshooting protocol called ICMP, if you want to, encapsulation protocol called PPP, and so on. Each layer has different type of protocol. Here is a comparison between the IP model and the OSI model. Remember that the IP model or the internet model, that's only, as you can see over here, 5 layers. The other one become 7 layers. Mostly cover the same concept. However, the functions been breaking down into smaller layers. Instead of the application layer, for example, take the whole thing as 3 layers. No. We break it down that application layer. It become 3 different layers, and each layer has its own function, services, and protocols, which I believe that's better, especially in terms of troubleshooting as well, not just understanding the concept, no, and following the concept as well in terms of troubleshoot. We have what we call the protocol, and as I told you that, don't forget that, the sets of rules and controls. All these layers add what we call it PDU at the message. What is that? What is that PDU? Header. Remember the word header. When you let me just show you that. If you go from the top, for example, I'm gonna give you a very basic, simple. I have a Word document, and I want to send that document. I type it in my computer, and I want to send it to my colleagues here in the other side. What's happening exactly? Very basic. You type it here, it goes over here into, you are here in the application layer. This is your document. Yes, here it is, your document, and that application layer will add its own header, the application layer header or the PDU, then pass it to the other layer, which is the session layer. The session layer will take that one. This is your data, and this is the header for the application, and it will add its own header as well. Then you pass it to the presentation layer. For example, that presentation layer, you pass it to the session layer. Here is the data, here is the application header, presentation layer, here is the session layer, and so on and so on. Every time you pass by, this is your data, you add header, another header, another header. Every time you come in, this is my data here, the Word document. The Word document, it add, as you can see over here, you add something too. Here it is, you keep adding. What is that exactly? Call it header. What's inside the header? Fields. What inside the field? Instructions as well. Really? Yes. So you actually moving from top to bottom to add header, and that header has instruction inside. Yes, and we will come closer to that in the next few weeks. If you want to point something about the network layer, matching layers communication between different computer and computer platform. If you want to do something, you have to create what we call standardization between systems. Imagine, and I want you to try to understand that. The Mac machines, the Apple computing machines, and the Windows. Those ones, they have different operating system based on different command line. One of them, which is the Windows, they use the DOS command, and the Mac is Linux or Linux command. So in short, two different machines, they speak two different language. However, you send the data from one computer to another, they receive and they understand each other. Who create that? The standardization. Standardization include modeling as the TCP/IP or the OSI model, the latest one, the OSI model. Is the OSI model has advantage? Yes, it is has a lot of advantage. It's make actual understanding of the concept of networking much easier. Troubleshooting become a lot easier, and the development of software or protocol become much easier because it become less headache. However, it has disadvantage as well. What is disadvantage? If you keep adding, for example, this is my document, which is the Word document. It's like, for example, this one is like, let's say, I'm gonna say 1 meg. When I try to send it, it end up with like 2 or 3 meg. Assumption. That's like an assumption, not the exact numbers. So my document is 1 meg. I have added headers, keep going like that, adding here until become another 2 megs. What does that exactly create? Overhead. Processing time, which means that increasing time. We have different protocol at each layer. The application layer, as you can see here, we have the most famous one, the POP and the IMAP and SMTP. And those one related to the email. The SMTP sending email, POP and IMAP receiving emails. And there is a difference between POP and IMAP for sure. We may cover that. The transport layer, the network layer, which is the most important protocol over there, is the IP. The data link layer, and that's involved with Ethernet frame relay, which is away from your study, the frame relay away from totally from your study. And the physical layer usually have standardization of category Cat 5 or Cat 7, whatever it is, the cable. However, we don't want you to memorize the common standards, but I want you to remember for each layer, let's say, the most famous protocols used in this layer. And we will cover that in the coming few weeks. Try to go over these materials, read, try to understand, and come up with any questions during the lab time. I'll be more than happy to go over anything you want. Study hard. I wish you all the best. Have a good one.